Solving absolute value equations. So we're going to start off with some simple equations in part 1. And our first example is the absolute value of x equals 5. So what we want to remember is that we're going to take everything that's inside the absolute values, in this case just x, and set it to the positive and negative versions of this number. So that's going to give us x equals 5 and x equals negative 5. And these are our two solutions. The reason they're solutions is because if I plug them in for x, the absolute value of 5 would give me my 5, and the absolute value of negative 5 is also 5. So those are both solutions. In example number 2, we know that we have to isolate the absolute value first. So the first thing I would do is change this subtraction to addition of the opposite sign. And I can see now that I need to get rid of this negative 6, so I would add 6 to both sides. And that gives me the absolute value of x. 6 plus negative 6 cancels. And that equals 8 plus 6, which is 14. So now I take what's inside the absolute values and set it equal to the positive and negative versions of this number. So I get x equals 14 and x equals negative 14. And those are my solutions. For number 3, I have this 4 here. So I know I need to isolate the absolute value, which means I'm going to have to subtract 4 from both sides. 4 minus 4 is 0, so that cancels, and I have the absolute value of m equals negative 5 minus 4 is negative 9. Now, when I look at the absolute value, I know that that's non-negative. That means it has to be 0 or positive. It's impossible to have a non-negative number equal to negative 9. You can't have a non-negative number equal to a negative number. So this equation has no solution. Once we state that it has no solution, we're done. In example number 4, our absolute value is already isolated, so there's nothing to do there. And it's set equal to 0. When it's set equal to 0, we're only going to get one equation because there is no negative version of 0. So we're going to get 3x equals 0. We've taken what's inside the absolute values and set it equal to the 0. Now all we have to do is solve the equation. So we divide by 3 on both sides. 3 divided by 3 is 1, and 1x is just x, so that cancels. And we get x equals 0 divided by 3 is 0. So our only solution is 0. We can check that by taking the 0 and plugging it in for x. This says 3 times x, so we do 3 times 0, which is 0. And the absolute value of 0 is 0, so it does check. In example 5, we have the absolute value of 5b plus 3 is equal to 2. So the first thing I check is that my absolute value is isolated, and it is. There's nothing outside of the absolute value signs. And then I check my number. That's a non-negative number. 2 is a positive 2. So we know that this will have solutions. And this means that we're going to have to set up our two equations. So my first equation is 5b plus 3 equals 2. Remember, we get the first equation by dropping the absolute value bars. And our second equation is going to be 5b plus 3 equals negative 2. So the only difference between those two equations is my number. First I use the positive version, then I use the negative version. So if I look at the first equation, 5b plus 3 equals 2, first thing I'm going to have to do to solve it is subtract 3 from both sides. That'll give me 5b equals 2 minus 3 is negative 1. And then, to get rid of the multiplication of 5, I need to divide by 5 on both sides. That gives me b equals negative 1/5. So that's my first solution. In my second equation, I need to subtract 3 from both sides. That gives me 5b is equal to, and then negative 2 minus 3 gives me negative 5. Now, just like in the previous equation, I divide by 5 on both sides. 5 divided by 5 is 1, so it cancels. And I have b equals negative 5 divided by 5 is negative 1. So the two solutions to this equation are b equals negative 1/5 and b equals negative 1.